All right, this video is going to be much shorter and in much less detail, partly because I'm showing my limitations now. I'm not a physics major. I don't know a lot about all this stuff. And so the particle behaviors of light that we're going to look at now, when you get into the particle nature of light, you get a lot more into subatomic particles and levels of physics that I never took in college. I don't know about very well. Some of you may very well know more about this than I do. So we're going to really just dust the top of this. But there are a couple of things that light does that do indicate that it is not only a wave, it's also a particle. And those two things are the photoelectric effect and what I'm going to call is the light pushes stuff, the solar wind. There are other things like we can talk about atomic line spectra and emission spectra. I'm not going to discuss that because it would take too long. I would have to go into too much detail. So let's go to the photoelectric effect and go ahead and talk about it. Basically, what the photoelectric effect is when light shines on a piece of metal, special piece of metal, we've observed that electricity flows. Well, we know that electricity is the flow of electrons, and electrons are matter, right? So this is an interesting, curious thing that happens. But what is interesting is that we cannot use only the wave nature of light to explain this, okay? Because we said at the very beginning of this whole waves unit that waves don't transfer matter. Waves do not cause the transfer of matter, so we cannot use the wave nature of light to explain the fact that when light shines on a piece of metal, electrons jump off. It can cause electrons to flow, electric current to flow. So that's one of the reasons why we postulated that, not we, but someone else other than me, way smarter than me, that light is made of particles, and those particles are called photons. Now, a photon is simply a massless particle, a massless piece of light that has a specific amount of energy, and we'll talk about in the solar wind about the energy associated with that photon. And actually, when we get to nuclear, we'll learn that energy and mass are flip sides of the same coin. So we got some interesting nuclear stuff going on there. But the energy that light has, as we discovered in the virtual lab at the beginning of this lesson, it depends on the frequency. I'm hoping that you learned and remembered that on the blue-violet end, for instance, as far as visible light is concerned, those are the high frequency and high energy colors of light, whereas on the red-orange end, we have low frequency and low energy. And that's also true with the entire electromagnetic spectrum. I gave you the red Martians invaded Venus using X-ray guns. That phrase to help you remember the whole spectrum. But the X-rays and the gamma rays are on the high energy, high frequency end. So a photon, the amount of energy associated with a photon depends on its frequency, which is color for visible light, but just different frequencies even if it's not visible. You are probably most familiar with the photoelectric effect in stuff like this or stuff like this. This is how we generate electricity through solar energy. That's how we get solar power. These solar panels are made up of a special kind of metal that basically when light shines on it, it causes electrons to flow particularly to one terminal, and that's an electric current. We're building up electric charge, and we deliver that electric charge to batteries to be stored for later. And so photoelectric effect is the first particle behavior of light that I need you to know. Second particle behavior of light is this solar wind business, the fact that light pushes stuff. Now I'm going to show you a video. The next video on here is a video from this Physics Girl YouTube channel. She really explains it well. But in effect, you need to know that, and you've probably never thought about this before, that for instance, when astronauts go to the moon, the light from the sun can act as wind. It can push the spacecraft off course, just like the wind can push an airplane off course. And we know that wind is a particle, it's matter. Well, light is too, because it does the same thing. And so astronauts actually have to account for the solar wind in order to get to where they need to go. We actually have to understand how much they're going to be pushed off course by light. And it's not really a tiny amount. As you'll see in this video, it can be quite a bit. So watch this next video. It's called the solar wind. But basically, after you get through with that video, that'll be the end of this lesson in this unit. But what you need to remember about light is its nature is dual. It has a dual nature. It is both a wave and a particle at the same time. And we've talked about several behaviors to support that idea.